Hey, I just want to show you one more thing from the packet on page 42. So Mrs. Davis showed you how to prove that a parallelogram is, or at a quadrilateral rather, is a parallelogram using opposite sides congruent or opposite sides parallel. But I'd also like to show you how to prove it using that the diagonals bisect each other. So I went ahead and I graphed the quadrilateral that we're trying to prove is a parallelogram. This is the same one from page 42. And what I'm going to use is the midpoint formula. The midpoint formula states that I take the two x values, add them together and divide by 2. I'm finding the average, and do the same thing with the y values. So the goal here is to prove that they bisect each other means that if I draw these diagonals in, so if I just connect and create the diagonals from each side, that the point where they intersect should bisect both of these. And what's going to happen is that should mean that both of these line segments should end up with the same midpoint. So I know a midpoint divides it in two. So if both segments have the same midpoint, then that's going to prove that the diagonals bisect each other. So let's look at the midpoint of line segment SU. So I'll take my x value, -2 plus 6 divided by 2, and I'll take my y values, 3 plus 3 divided by 2. And if I simplify that, -2 plus 6 gives me 4 over 2. 3 plus 3 is 6 divided by 2. And so I'm going to get 2, 3. That's, and I can, the midpoint of SU. I can see that right here. Here's my x value of 2, my y value of 3. So in this one, it worked out. I could just see it. Let's prove it for TV. So the midpoint of line segment TV. So I have my x values, 1 plus 3 divided by 2, and 5 plus 1 divided by 2. 1 plus 3 is 4 divided by 2. 5 plus 1 is 6 divided by 2. And so I get the ordered pair 2, 3. I know that STUV is a parallelogram since both diagonals share the same midpoint and thus bisect each other. Logic and reasoning.